Hey guys, we've got another open source battery for you guys. These are all free to download, all of these parts. We've got two designs. These are both good for 48 or 52 volt 15 amp hour or 36 volt 20 amp hour using 2170 cells. This design has the straps parts already printed into the part, and then if you have an extra tight frame, you can put the strap parts on afterwards. You can slide the battery into place and then bolt down those strap areas. So we're going to show you how to build this battery on today's video.
Hey guys, welcome back to the Electric Bike Laboratory. I'm Samil, and today we're going to be building a 48 volt 15 amp hour compact triangle battery, so let's get to it.
All right guys, let's talk a little bit about the design of this battery. So we wanted this battery to be as compact as possible. That's why we call it the compact triangle battery. And to do that, we did a couple decisions in the design, which would make it be able to fit in as most amount of bike frames as possible. So as you can see, we have the bars that the Velcro straps would tie through. They are bolted in place, and that is intentional because sometimes the frame is so tight that you can't actually fit the battery in. So this way, what we can do is you can take off the bars on one side, put the battery into the frame, and then screw them back in, and that's gonna allow just that little bit of extra clearance. Another thing is, if you look on all parts of the battery, we have a little cutout for the tubes, and that's gonna allow just a few more millimeters of clearance. So we have it on this side, and this side. And that really gives this battery a super low profile in the bike. Another thing that we wanted to include was, again, our LCD display, and that gives you a pretty accurate read on your battery voltage. That turns on and off with the switch. And lastly, we've got charge port on the side. Our first revision, we had the switch on the side as well, but we noticed that riders would sometimes kick it with their knee and turn the battery off. To make this battery even more versatile, we made it be compatible with our universal base plate. So the universal base plate has a few ways that it can tie down to the bike. We've got water bottle holders that are spaced at that 65 millimeter spacing so that they can bolt down into a water bottle bosses. And then we've got all of the Velcro strap openings. So you can even just, if you don't have water bottle bosses, you can use the Velcro straps to tie to the bike. And it has locking dowels so that the battery is able to fit directly on, and then it locks it in place. And that's where we would have this bar. So you could use one Velcro strap to hold the battery down if you wanted it to be mounted similar to like a down tube battery on the water bottle bosses. And that's still gonna allow your display to be visible and your switch to be accessible. So a bunch of our battery designs incorporate the same functionality of being able to mount to this, what we call universal battery mount. Okay. So on a frame like this, if we take a battery like this guy, this is the Rienshin DP4C, allows for 48 volt 15 amp hour, 39 cells, 21700. And you would think that that would be able to fit into this frame, but if you look closely, it doesn't quite fit, just not quite enough space. The rear shock takes up some space, and then the top tube tapers down first before it becomes straight. So you can't actually get this battery in place safely, or if you do, you're gonna jam it in and you're never gonna be able to remove it. So the 48 volt 15 amp hour, with the triangle battery, you're able to fit that same amount of capacity, but it's obviously able to fit into the frame much easier with quite a bit of room to spare even. So it is a really versatile battery, super easy to print too, because it's not exactly a big form factor. So you're able to print these parts on like a pretty small printer. But yeah, so a quick look at kind of the versatility of this fairly simple battery design. You can download all the parts off our website. I will show you where to do that, but hopefully it works well for your project.
Okay, so for our build, we're going to be using Samsung 50E cells. These are 21700 cells with a voltage of 3.7 volts, a capacity of 5000 milliamp hours, and it can do 10 amps of continuous discharge current and then 15 amps peak discharge current. So we're going to be putting it in a 13S 3P configuration. 13S, which is 13 in series, will give us 48 volts, and then 3 in parallel will give us 15 amp hours total. So the BMS we're going to be using is the DALY 13S 30 amp BMS. Okay, and these are the cell holders we're going to be using. They're custom 3D printed cell holders with 13S 3P configuration, so 39 cells. And we're going to be using this custom 3D printed plastic case to put our battery in, and the cell holders kind of nicely fit in there, as you can see. So the first step would be to put the cells in a 13S 3P configuration. So I'm going to be making up a pattern here where the cells are neatly organized. And before you put the cells in, it's always a good idea to check the voltage of each cell to make sure they're within 0.01 range. But these cells come out of the box brand new at about 3.5 volts for each cell. I put the cells into the cell holders in a 13S 3P configuration. So this will be my negative terminal to start with, and then 3 positive, 3 negative, all the way alternating to the end. And then these 3 cells on the other side will be my positive terminal. So these 3 cells will be my positive terminal on the other side. So I'm going to spot weld all the cells together now and then put the BMS on. I spot welded the whole pack together now, and I've used 0.2 by 10 millimeter wide nickel, so 0.2 thick and 10 millimeters wide, and each piece of nickel can flow 10 amps of current. So I put 3 series connections across each of the groups, so that'll support 30 amps since our BMS will be drawing 30 amps continuously. And I've isolated the negative terminal on this side and then welded the rest of the pack on this side, and then on the other side I isolated my positive terminal and then done the same, and the current will flow across the pack. So the next step I will do is I'll wrap the sides with Kapton tape. Then I will put solder points on each of the cell groups so my BMS balance lead wires can go on. So I'm going to be using some flux to put on the points that I scratched so the solder can stick on there nicely. I put bigger solder points on the negative terminal for the battery negative wire to go on, and then little solder points on each of the groups for the balance leads to go on. Then on the other side, the same thing, bigger solder points on the positive for the positive discharge wire, and then little solder points on each of the groups for balance leads. I can now wrap this pack up with Kapton and then snip off the solder points so the balance leads can go on. And then I'll also do the side, cover the sides up with fish paper so the BMS can rest on top. So the battery negative wire and the negative discharge wire that comes on the BMS are 14 gauge. So I'm going to desolder these wires and then put on 12 gauge wires so they can carry more current. I have a smaller wire for the battery negative, and then a longer measured wire for the negative discharge. Now I put the 12 gauge wires onto the BMS. I soldered them in where the previous wires were, and I added some extra solder for more support. Now we can put the BMS on the battery. For the temperature wire here, I will make a slit through the Kapton and the fish paper, then I will glue it right on top one of the cells. Then I will fold over the battery negative wire and then solder it on to the negative terminal. Then afterwards I will do my balance leads and organize them neatly and run them to each of the groups. This double-sided sticky tape will help the balance lead stick on, and I can organize it neatly along the battery. So for my balance leads here, the black one is negative, which will go on the negative terminal, and then each one will be alternating until the end you get to the positive where the last balance lead will go. I put on all the balance leads to each of the groups, and anywhere where the balance leads go over the cells, I put fish paper underneath so it won't directly come into contact with the cells at any point. And at any point where the balance leads ran over top of each other, I put Kapton tape to separate them. Now I can plug the balance leads into a balancer and check if all the groups are reading good, and then I can charge the pack up, discharge it, and then recheck the balance on the pack to make sure all the welds are good and all the cells are good. These are going to be our mounting brackets for this case, and the mounting brackets will get screwed into each of the points here, but for our purpose we're only going to be using the front ones and the bottom ones. That's because the battery will sit on the bike frame like this and get mounted here and on the bottom. The mounting brackets will get screwed in with these screws here. So I will pre-drill each of the holes just on the top and on the bottom here. The components that will go on the case will be the display, the battery indicating display, the switch in here, and then the charge port in there, and then the discharge cables will exit this way. So for the charge port, I'm going to pre-solder wires and put an XT30 connector on it, and then I will have a separate 2 wires coming from the pack with the female XT30, and then it can connect to the charge port. And the display wires I will put right on the battery, and then it can plug into the back of the display. And then for the switch wires, I will put a small connector and then put a connector also on the wires coming out of the battery. The battery indicating display will get screwed in with these little screws here. So the switch port, I put a connector on, and then on the switch wires that will be coming out of the battery, I will put the female connector on. Likewise, on the charge port, I put an XT30 male connector, and then on the wires coming out of the battery, I'll put an XT30 female so it can plug in. And then the display wires I will put right on the battery, and then that can plug into the display. So I put my charge port and my switch and my display in. Now I will glue around them to seal them and make them watertight. After the pack was charged up to full, I did a discharge at 30 amps for 10 minutes. And this is the results after, as you can see here on the screen. The pack is at 009 and all the groups are reading good. So now we can go on to finishing up the battery and then putting it in the case. I can now put a positive discharge wire about the same length as his negative discharge wire here, and then I will run two 18 gauge wires connected to the XD30 as a charge so it can connect to the charge port. Then I will put this connector on my switch wires, and then I will also have this running out the display indicator wire going to the positive and the negative so it can connect to the display. I'm going to shoot little bits of glue over the balance leads to cover them up, and then I will also cover up my battery negative terminal. I can cover up the sides with fish paper and cover the exposed balance leads with fish paper before I run all my charge wires and my discharge wires. I've got all my connectors on the pack now. I can seal it up with blue tape, which serves the same purpose as blue heat shrink to kind of give it a protective layer and make it sort of water resistant. And then afterwards we can put it into the pack, run the discharge wires out, connect all the connectors, and then seal up the pack. Okay, so I sealed up this pack with blue tape, and now I can put it into the case. Before I do that, I will connect my display wire, or battery indicator wire, the switch wires, and then afterwards I'll connect my XD30, and then I also want to run my discharge wires out of these two holes on the case first. The pack is inside the case, nice and tight now. I can put on my discharge connector, then make sure all the ports are working, the charge port, the display, the switch, and then afterwards I can put the lid on. Okay, so we will first test out the switch. As you can see, that turns on the battery, and then I will discharge it on about 14 amps and check that it's working. Next, I can check the charge port. So I will plug this connector into the charge port. As you can see, it is charging at 8 amps, so it's working. So here I have some gasket sealant, which is this gasket maker, and I put some in this syringe so I can apply thin amount. First, I will put it around these cable exits and seal that up. And then when I put the lid on, I will apply it around the lid to seal it and then put the screws in. Okay, so now after the screws are in on the lid, I can clean off the excess sealant off with what I like to use is Goo Gone, or you can use any sort of cleaner. I will now pre-drill these mounting points so these bolts can go through it, and then these mounts will screw onto the case. So what I will do is I will pre-insert these screws into the mounting brackets, and then once a little bit is exposed of the screw, I can line it up with the holes here, and then I can secure them on. So depending on how you want to mount this pack onto your bike, you can use these extra mounting points on the top, on the side if you want to use it. Basically with these mounting brackets, you can put straps through the tube and then secure the pack onto the bike. As you can see here, I got my 1, 2, 3, 4 mounting brackets on for our purposes, but the rest of the holes are sealed up. And then I put water sealing gasket around the cable exits as well as around the lid. So this is the finished pack now. So here we have our finished 48 volt 15 amp hour compact triangle battery in a custom 3D printed case. If you enjoyed the video, make sure to leave a like. If you have any questions or thoughts, please leave a comment. If you haven't subscribed, make sure to subscribe to our channel and stay tuned for the next video.